When you have a 480 volt service and require 277 volts for lighting, and there is no neutral available, there are primarily two options to consider. The first option is to use a 480 to 277 volt transformer. You would install a step-down transformer specifically designed to convert 480 volts to 277 volts. Connect the 480 volt service wires to the primary terminals of this transformer. The secondary terminals of the transformer will then provide the desired 277 volt output for your lighting circuits. The second option involves using autotransformers. In this scenario, you would employ two 480 to 240 volt autotransformers. Connect the 480 volt service to the primary terminals of both autotransformers. Then carefully wire the secondary terminals of the autotransformers in a manner that produces the required 277 volts. This often involves connecting the secondary windings in series or a buck boost configuration. Regardless of the method chosen, certain crucial considerations must be addressed. Firstly, grounding is of utmost importance. Ensure that the transformer or autotransformers are properly grounded according to electrical codes and best practices. This grounding is essential for safety and to prevent electrical hazards. Secondly, appropriate circuit protection must be installed. This means incorporating a circuit breaker or fuse of the correct amperage rating to protect the 277 volt lighting circuit from overcurrent conditions. The size of this breaker or fuse will depend on the load requirements of the lighting fixtures. Thirdly, strict compliance with all applicable electrical codes and regulations is non-negotiable. Adhering to these codes ensures the safety and legality of the installation. These codes vary depending on location, so understanding the local requirements is critical. The decision of which method to employ hinges on several factors. The available physical space for equipment is a practical consideration. The cost of the transformer versus the autotransformers and associated components will impact the budget. The specific load requirements of the lighting system, including the total wattage and voltage needs, will also guide the choice. Consulting with a licensed electrician is highly recommended. A qualified electrician can assess the specific situation, provide expert guidance, and ensure that the installation is performed safely and in full compliance with all applicable codes. Remember that working with electricity can be dangerous, and professional expertise is invaluable. If a neutral wire were available, it would broaden the options. The presence of a neutral would allow for the use of single-phase 120 volt or 240 volt loads, in addition to the 277 volt lighting. However, in the absence of a neutral, the transformer or autotransformer solutions are the primary means of deriving 277 volts from a 480 volt service. Considering additional factors when selecting between a transformer and autotransformers can be beneficial. Transformers provide electrical isolation between the primary and secondary circuits, which can enhance safety and reduce the risk of ground faults. Autotransformers, on the other hand, do not provide this isolation as the primary and secondary circuits are electrically connected. In terms of efficiency, autotransformers are generally more efficient than transformers because a portion of the voltage transformation occurs directly through the winding, rather than through electromagnetic induction. This can result in lower energy losses and reduced operating costs, especially in high-load applications. Size and weight are also important considerations. Autotransformers are typically smaller and lighter than transformers of comparable volt-ampere rating. This can be advantageous in situations where space or weight restrictions are a concern. Furthermore, transformers may offer better voltage regulation than autotransformers, meaning they maintain a more stable output voltage under varying load conditions. This can be important for sensitive lighting systems that require a consistent voltage supply. Before making any decisions, it is crucial to perform a thorough load calculation to determine the total volt-ampere demand of the 277 volt lighting system. This calculation should take into account the wattage of all the lighting fixtures, as well as any other loads that will be connected to the circuit. The transformer or autotransformer should be sized to handle this total volt-ampere demand, with some additional capacity for future expansion. In addition to the main transformer or autotransformers, it may also be necessary to install additional components, such as surge protectors, to protect the lighting system from voltage spikes and transients. Surge protectors can help to extend the life of the lighting fixtures and prevent damage to sensitive electronic components. It is also important to consider the environmental conditions in which the transformer or autotransformers will be installed. If the equipment will be exposed to moisture, dust, or extreme temperatures, it may be necessary to choose a model that is specifically designed for these conditions. Finally, remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician before making any changes to your electrical system. A licensed electrician can help you to select the right equipment, ensure that the installation is done safely and correctly, and provide ongoing maintenance and support. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in the United States. It is essential to follow all applicable NEC requirements when installing a transformer or autotransformer to convert 480 volts to 277 volts. Some key NEC sections to consider include Article 450, which covers transformers, and Article 210, which covers branch circuits. Specifically, NEC Section 450.3 addresses overcurrent protection for transformers, while NEC Section 210.20 covers overcurrent protection for branch circuits. It is also important to ensure that the transformer or autotransformer is properly labeled with all relevant information, such as the voltage rating, volt-ampere rating, and impedance. This information is necessary for safe operation and maintenance. When selecting a transformer or autotransformer, it is important to choose a model that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL listing indicates that the equipment has been tested and found to meet certain safety standards. In addition to the NEC, there may also be local electrical codes and regulations that apply to your installation. It is important to check with your local building department to determine the specific requirements in your area. Proper grounding is critical for electrical safety. The grounding system should be designed to provide a low impedance path for fault currents to return to the source, which helps to protect people and equipment from electrical shock and damage. NEC Article 250 provides detailed requirements for grounding electrical systems. When installing a transformer or autotransformer, it is important to ensure that the equipment is properly bonded to the grounding system. Bonding involves connecting all metal parts of the equipment to the grounding system, which helps to create a common ground potential and prevent voltage differences that could cause electrical shock. In addition to grounding and bonding, it is also important to provide adequate ventilation for the transformer or autotransformer. Transformers and autotransformers generate heat during operation, and excessive heat can damage the equipment and reduce its lifespan. Proper ventilation helps to dissipate this heat and keep the equipment cool. The manufacturer's instructions will specify the minimum ventilation requirements for the equipment. These requirements may include providing adequate clearance around the equipment and installing ventilation fans to circulate air. Regular maintenance is essential for ensuring the safe and reliable operation of a transformer or autotransformer. Maintenance tasks may include inspecting the equipment for damage, cleaning the equipment to remove dust and debris, and testing the equipment to verify its performance. The manufacturer's instructions will provide recommendations for maintenance procedures and schedules. If you are not qualified to perform electrical work, it is important to hire a licensed electrician to perform the installation and maintenance of the transformer or autotransformer. A licensed electrician has the knowledge, skills, and experience to do the job safely and correctly. When working with electricity, it is important to always follow safe work practices. These practices include wearing appropriate personal protective equipment, such as safety glasses and gloves, and energizing the circuit before working on it. If you are not sure how to de-energize a circuit safely, it is best to call a licensed electrician for assistance. Transformers are generally more robust in handling nonlinear loads compared to autotransformers. Nonlinear loads, such as those produced by electronic devices, can generate harmonics that can distort the voltage waveform and cause overheating in electrical equipment. Transformers, with their inherent isolation, tend to dampen these harmonics more effectively. The inrush current, when energizing a transformer, can be significantly higher than the normal operating current. This inrush current can trip circuit breakers if they are not properly sized. When selecting a transformer, it is important to consider the inrush current and choose a circuit breaker that is capable of handling it. Autotransformers are often more compact and lighter than transformers with the same volt-ampere rating. This can be a significant advantage in applications where space and weight are limited. However, it is important to note that the smaller size of autotransformers can also make them more susceptible to overheating if they are not properly ventilated. The impedance of a transformer or autotransformer affects the amount of fault current that will flow in the event of a short circuit. A lower impedance will result in a higher fault current, which can cause more damage to equipment. When selecting a transformer or autotransformer, it is important to consider the impedance and choose a device that is appropriate for the application. Transformers are available in a wide range of voltage ratings, volt-ampere ratings, and impedance values. This makes it possible to find a transformer that is specifically designed for your application. Autotransformers are typically available in a more limited range of ratings. However, they can often be custom designed to meet specific requirements. The core material used in a transformer or autotransformer can affect its efficiency, performance, and cost. Common core materials include silicon steel, amorphous metal, and ferrite. Silicon steel is a relatively inexpensive material that is suitable for many applications. Amorphous metal is a more expensive material that offers higher efficiency and lower losses. Ferrite is a ceramic material that is often used in high-frequency applications. The insulation system used in a transformer or autotransformer is critical for preventing electrical breakdown and ensuring safe operation. The insulation system should be designed to withstand the voltage stresses that will be encountered during operation, as well as environmental factors such as temperature, humidity, and contamination. Common insulation materials include paper, varnish, and epoxy resin. The tap changer on a transformer allows you to adjust the output voltage to compensate for variations in the input voltage. Tap changers can be either manual or automatic. Manual tap changers require you to physically move a switch to change the tap setting. Automatic tap changers use a control system to automatically adjust the tap setting to maintain a constant output voltage. The enclosure of a transformer or autotransformer protects the internal components from the environment and provides a safe means of connecting the equipment to the electrical system. Enclosures are available in a variety of materials such as steel, aluminum, and fiberglass. The enclosure should be selected to provide adequate protection for the environment in which the equipment will be installed. Noise can be a concern with transformers and autotransformers, especially in quiet environments. The noise is typically caused by the vibration of the core and windings. Noise levels can be reduced by using vibration damping materials and by selecting a transformer or autotransformer with a low noise rating. The life expectancy of a transformer or autotransformer depends on a number of factors, including the operating conditions, the maintenance practices, and the quality of the equipment. With proper maintenance, a transformer or autotransformer can last for many years. However, it is important to monitor the equipment for signs of wear and tear and to replace it when necessary. The cost of a transformer or autotransformer depends on its voltage rating, volt-ampere rating, impedance, features, and manufacturer. It is important to compare prices from different suppliers before making a purchase. Installation costs can vary depending on the complexity of the installation and the labor rates in your area. It is important to get several quotes from qualified electricians before starting the installation. Operating costs include the cost of electricity to power the transformer or autotransformer, as well as the cost of maintenance and repairs. More efficient transformers and autotransformers will have lower operating costs. Regulations and standards govern the design, manufacture, and installation of transformers and autotransformers. It is important to comply with all applicable regulations and standards to ensure the safety and reliability of the equipment. The increasing use of renewable energy sources, such as solar and wind, is creating new challenges for power distribution systems. Transformers and autotransformers are playing an important role in integrating these renewable energy sources into the grid. Smart grids are using advanced technologies to improve the efficiency and reliability of power distribution systems. Transformers and autotransformers are being equipped with sensors and communication devices to enable them to participate in smart grid applications. The development of new materials and technologies is leading to more efficient, compact, and reliable transformers and autotransformers. These advancements are helping to reduce energy consumption and improve the performance of electrical systems. Remember to thoroughly assess the specific requirements of the lighting system, consider all relevant factors, and consult with qualified professionals to ensure a safe, compliant, and efficient installation.